All right, here we are at the mechanical energy conservation example. That is a mouthful. So in this case, we have a 25 kilogram child plays on a swing having support ropes of 2.2 meters long. A friend pulls her back until she reaches 42 degrees from the vertical and releases her from rest. How fast will she be moving when she reaches the bottom of the swing? All right. So I notice that we go from one point to another point. So because I'm going from one point to another point, and I'm talking about speeds, I'm going to be setting up my work kinetic energy theorem. So what we have to keep in mind here is, yes, her friend did pull her back. So her friend did do work, but on the way from point 1 to point 2, her friend is no longer involved, and so there is no work because her friend was no longer applying a force. So there was no applied force. We are going to ignore air resistance, so there's no work done by friction. And this is why this is a conservation of mechanical energy example, because we have no work in and no work done by friction. So whenever both of these are zero, it's called a mechanical energy conservation problem as opposed to just a work kinetic energy problem. All right, so our friend has released us from rest. We are going to have some speed down here at the bottom. So yes, there is speed at point 2, but there is none at point 1 because it starts at rest. We need to choose where is height going to be 0. So I'm going to choose it at the lower of my 2 points here. So this point down here, I'm going to call my height equals 0. And so I just need to go ahead and find the height at which it starts at. I'm just going to use the kind of the bottom of this string as my single point of interest here. So that means that at the end, there is no gravitational potential energy because your height is 0. Also, we're going to assume that these chains, or did they say ropes? I forget. Ropes, that they are not stretching or compressing at all. So we're going to assume they have no energy stored in them. There's no springs. All right. With that said, we have narrowed this equation down drastically, and so it might start to seem, oh, this is going to be a little easier. So I have my kinetic energy, 1/2 mv squared, minus my gravitational potential energy, which is mgh. Oh, I see I have an m in every term. Yes, you are correct. And if I have an m in every term, the m's cancel. This is going pretty well. So now I just got to find v. And so v is going to be the square root of 2gh. Simple enough. All I got to know is the height. 2.2 meters, 42 degrees. Here is where it gets difficult in this situation. So this is a situation where we have a pendulum. So what we're going to do is we're going to go ahead and put a big star in our notebook here, and we're going to write pendulum. And when we write pendulum there, we are going to remind ourselves, how do we find height in the case of a pendulum, specifically one where they give us the length of the pendulum and the angle it has been displaced. All right, so here's how this works. So I am trying to find this height here. That is my goal. But looking at this triangle up here, I should be able to find this value right here. I'm going to call it x. And so x here is going to be adjacent to my angle, so it's going to be the length times the cosine of my angle, or in this case, it's going to be 2.2 cosine of 42 degrees. So now I know what that x is, and I do know the length of my string. It's that 2.2 meters. So if I want to find this height, I just have to take that total length, subtract off that x value, and we'll have our number. So let's see what that looks like. So my height is going to be my length minus x. So my height is going to be my length minus my length cosine of my angle. If you want, you can factor out an L. So you have L times 1 minus cosine of theta. This is the generic format of it for finding it when we have a pendulum. If we plug in our numbers here, we're going to have a height which is equal to 2.2 times 1 minus the cosine of 42 degrees. When we plug that in, we get a value of 0.565 meters. We now know our height. We can plug it in over here, and find our speed. 2 times 9.8 times my height, which was 0.565, and you should get a speed down there at the bottom of 3.33 meters per second. A good speed for some fun on the swings.